This is a tutorial to show how to build a bicycle saddle using surfacing technique. The surfaces will be turned into a solid body, and then the bottom of the saddle or seat will be shelled out. Last semester we built a similar bicycle seat, but we did it completely with solid modeling because we didn't know how to use surfaces. Because of this, we had to use a few workarounds and compromises to get what we want, because solids do not have the same level of versatility that surfaces do. Our goal was to build only one half of the seat and then be able to mirror it to the other side and have it join seamlessly together without a ridge or valley along the join. Unfortunately, when modeling in surfaces using a boundary, it's hard to control the shape of the boundary where it meets our mirror plane, and we weren't able to use a normal to profile control like we would with a surface. To get around this problem, we actually had to build some excess to the boundary, and that allowed us to make the upper face of the boundary normal to the guide curves that were sitting in the mirror plane located here. We were then able to trim off that excess and then finally mirror the seat to the other side. This was somewhat awkward because every profile of the boundary had to have this excess portion drawn into the profile, and this got to be a bit tedious. In addition to this, it added the potential for making mistakes. Another issue we had to deal with was the fact that the boundary is going from a point at this end to a point at this end. It leaves us with a degenerate point at both ends of the boundary, which makes it very difficult to shell the solid boundary. To get around this problem, what we did was we left a very slight flat at either end of the boundary to get rid of the degenerate point. Then we tried to obscure that by adding a fillet on the end and then a fillet on the bottom edge and hope that nobody noticed this little compromise that we put in here. With surface modeling, we'll be able to eliminate all these compromises and model exactly what we want. For this tutorial, we are starting out with a layout of the seat on the front plane and a layout of the seat on the top plane. From these layouts, we are able to make a projected curve, which will be our outer guide curve for the boundary. We then have made a series of planes, and at each of these planes is where each profile is drawn. If I hide the layout sketches, we can see now that what we've got is a top guide copied from the front layout sketch, our outer guide curve, which is a projected sketch, and these profiles, which have a Pierce relation to the upper guide and this outer guide. So I've got everything I need to start. The first thing I will do is make the boundary that will go from this end to this end and accept the fact that we'll have a degenerate point at either end. So going to my Surfaces tab and selecting Boundary Surface. For Direction 1, I will select this upper guide, which is a sketch on the mirror plane, and this outer guide, which is the projected sketch. I will set this curve on the mirror plane to normal to profile. And for Direction 2, I will select all my profiles in order. I think it might be easier to do that off of my feature tree, so I'll just select those right here. And finish. If I look at the end of my boundary and turn on curvature, I can see what the effect of that degenerate point is here, where I've got a little bit of a pinch. That's going to cause us problems if we try to shell this later on. I also can see how curvy this is in this area, and it's flattening out a little bit in this area. So if I go back and edit this boundary, and I go to the top guide, I see that it's set to none, even though I thought I set this to normal to profile. So I'll go back down and set this to normal to profile. And I also have a control here, which is tangency influence. If I don't want this area here to collapse, because it's a little bit of a good distance from this profile to this end, I can get this to sort of balloon out a little bit more by increasing the tangency influence. So I'm just going to increase that all the way to 100%. This will give this a little bit of a better shape here and not flatten out through this area. So that completes step 1. The next thing I need to do is trim off the ends of the seat where these degenerate points are located, and then patch these back in with a fill surface. Before I do that, though, I need to preserve the memory of where this original edge is and where this original edge is, so that when I add the fill surface, I can reestablish these two edges that have been removed in the trimmed off area. This edge is a three-dimensional curve, and I could preserve this edge by simply making a 3D sketch and then using convert entities to copy this edge. But that's a little problematic because I only need a little piece of edge here and a little piece of edge back here, and trimming this 3D curve back to this point and this point is usually somewhat difficult and not very reliable. Instead, I'm going to use a different technique. On my right plane, I will make a new sketch. Just simply draw a vertical line. The height of the line isn't too important, but I'll just make it 10 millimeters. And I will make sure that there's a pierce relation between this edge and this point. And I will finish that sketch. Now I'm going to take just this single line and sweep it along this edge here. So going back to Surfaces, Swept Surface, I select this as my profile, and this edge is my path. We take a look at that, we see that this twists around quite a bit. Because it's following a path, it's twisting around a lot in 3D space. All we have to do is go to our options and change from follow path to keep normal constant. Now what we have is something that looks like a curtain hanging straight down from this edge. Finish this, and that completes step 2. The height of this ribbon is unimportant. What is important is that the top edge of the ribbon preserves the memory of this bottom edge of the boundary. And so that when we trim away this end of the nose here, we will still have the original location of the edge preserved in this sweep. We also need to preserve the memory of this edge. And in addition to that, we need to have a surface to attach our fill surface to. You'll recall that fill surfaces do not have a normal to profile option. So if we can extrude a surface going in this direction, that will be a convenient surface to attach the fill to and set it to tangent to face. So all we have to do on our front plane is again make a sketch, click on this edge of the boundary, convert entities, and then go to our surfaces and extrude that. We want the extrusion to go in this direction, and 10 millimeters will be fine. The distance is not important. Now comes the fun part. We want to trim away the nose and the tail, but also trim this surface and this surface, so just the appropriate portion of edge is left over to make it easy to attach a fill surface. Looking at this from the top, on my top plane I will draw a new sketch. Just simply draw a three-sided profile, and I will make it about 4 millimeters from either end. This is to guarantee that I'm going to cut away that degenerate point at either end. And I just want to make sure that this goes well past these surfaces and that this line is well wide of this boundary. So now I can go to my Surfaces tab and select Trim Surface, and make sure that the standard option is selected. It's already selected the sketch that I'm working with as my trim tool, and I can choose Keep Surfaces or Remove Surfaces. I'll leave it at Keep Surfaces, and then what I will do is I want to keep this portion here, and I want to keep this portion here, and this portion here. You see what we are going to have is 3 surfaces coming together at points, leaving this area here open, and we will do the same on the back, keeping this surface here and this surface here. Hitting our check mark, we now see that we've got an open portion here, but it's surrounded by 3 edges that will be convenient for a fill surface, and the same thing is happening on this end as well. That completes step number 4. Steps 5 and 6 will be to add these fill surfaces to the nose and tail. I will start with the tail. Doesn't matter which one I start with. Now I go to my filled surface and I just select these 3 edges. The first edge, which is contacting my boundary, should be set to curvature so that there's a smooth blend back into the original boundary. The second edge, which is along the edge that was preserved by my sweep, can just be left at contact. And the last edge, which is at my mirror plane, should be set to tangent. The effect here is having a normal to profile control on this edge for the fill, but we don't really have that for a fill, so this is our workaround to attach the fill to a surface which has been extruded normal to our mirror plane. So we just finish that, and there's our patched in surface. If we go to our zebra stripes, you see how that smoothly blends in with the original boundary. Now we can do the same with the nose, the exact same procedure, clicking on these three edges. The first edge we will set to tangent, the second edge we will set to curvature, and the last edge, which is down on the bottom of the seat, we leave at contact. And that completes steps 5 and 6. So you see how easy it was to make this as a sweep and then use the trim to trim this surface back to this corner. That's a lot easier than trying to copy a 3D edge into a 3D sketch and then trim that 3D curve, which tends to be unreliable. But by using one trim command, we were able to get rid of this piece here and be left with this piece and this piece. Now it's time to do a little housekeeping. We've got 4 temporary surfaces that we don't need. We can go up into Insert, Feature, Delete Body, and we can select the bodies directly on the screen. So we'll select this one, and this one, and this one. And that completes step number 7. Now we see that where the fill surfaces are joining with the boundary, we still have a blue line here instead of a black line. So the next obvious step is to simply knit these surfaces together. So knitting this, this, and this. We now see this line is black, and we have a single surface body in our surface body folder. That completes step 8. The next series of steps are going to be to turn this into a solid body, which can then be shelled. In order to do this, we need to have a surface on the bottom that will cap off this bottom contour and a surface on the mirror plane. So we'll have a total of 3 surface bodies that we will knit together to form one chunk. We can start with the bottom surface. And one way to do this is simply copy these bottom edges into the front plane and then extrude the surface. But because this edge is 3 pieces now, it might be easier to go back to our original layout sketch and copy the bottom contour from the layout. So making my layout sketch visible again, front plane, sketch, and I will just copy this bottom contour, convert entities, and then I can just go back to surfaces and extrude that. And all I have to do is extrude this far enough to make sure that it's well wide of the seat. So that was step 9. Now selecting Trim Surface, I can select my upper boundary as my trim tool. And I will now select Remove Selections and hover over this outer area that I want to get rid of. That trims away the excess, leaving me with a nice smooth curved bottom. The last thing to do is fill in a planar area that will cap off the seat on the mirror plane. That was step 10 we just completed incidentally. So to make this surface on the mirror plane, once again what I will do is make a sketch on the front plane, turn my sketches back on, and I will simply copy the upper and lower contour from my layout sketch. So clicking on this edge here, convert entities. This edge here, convert entities. Let me hide sketches so you can see that. And here we have the upper and lower contour. Go back to surfaces and select planar surface. That was step 11. Now what I've got are 3 surface bodies which are completely enclosing a volume. And I can go back to Knit Surface, click on each of these bodies. When I do that, the Try to Form Solid option suddenly becomes visible, and I can check this, hit the green check mark, and now what has happened is it's knitted these together and at the same time turned this into a solid body. And if we look at the top here, we see that the solid bodies folder is here now, but not the surface bodies folder. That was step 12. I'm now ready to mirror this solid body. So just going to my features, mirror. My front plane is my mirror plane. My body is this entire solid body. And I want to make sure that Merge Solids is checked. That completes step 13. Now, if we've done this right, we can go to our Evaluate tab, click on Zebra Stripes, and we see how the fill surfaces are blending nicely with the boundary surfaces, and we see that the mirrored surfaces are blending nicely with the original surfaces. Now we're in the home stretch. All we have to do is shell this. We have a nice bottom surface for doing that without any little artifacts or split lines or anything like that. So we go back to Features, Shell. I will set this to 4 millimeters. Click on this surface here. Here we see this shells nicely without anything weird going on in the inside. You can see the shelled portion of the fill surface, both at the tail and at the nose. That was step 14, and our final step is to add a fillet both on the outer edge and the inner edge. We'll make that 1 millimeter. The easy way to do that is just set that to 1 millimeter. Instead of clicking on the edges, we can just click on this entire face, and that should fillet both the inner and outer edge at the same time. So now what we have is a nice completed seat that has no compromises like a small flat on the end. We have a very good shell on the inside without any weird surface artifacts like you might have had when you did this with solids. It took a few extra steps to do it this way, but each of the steps was easy and I think less fraught with error than all the workarounds we had to do when we built the solid version. I will mention there was one other way that we could have knitted together all the surfaces to create the solid. So I'll just roll this back for a moment to show how to do that. Right after we knitted together the boundary and the fill surfaces, we made the extruded surface that would represent the bottom face of the seat. And then we trimmed away this excess material. I think there's a way to avoid doing that trim and also to be able to do the planar surface on the mirror plane. So we'll start here with this knitted boundary and fill and this extruded bottom surface. And on the mirror plane, what we will do is not even bother trying to make a planar surface to perfectly match the shape of the seat. I'll just draw an arbitrary rectangle out here. You simply make that the planar surface, which is obviously way too big. But now what we do is we go to our trim. This time we use the mutual option. We will select all 3 of these surface bodies. And then I'll select Keep Selections, highlight this box, and I'll click on the pieces that I want to keep. Hitting the check mark, you see what that does is it trims everything back to just forming the enclosed seat, and at the same time it's knitting all of the surfaces together. Now this is still a surface body, this is hollow inside, so to turn it into a solid body, I go to my Thicken command, and I have an option here, Create Solid from Enclosed Volume. So I just check that, hit my check mark, and now this should be a solid body. And we see here that the Surface Bodies folder has disappeared from the top of the feature tree. Both methods take the same number of steps, so it's up to you which is more appealing. The one advantage of this method is that when you build a planar surface on the mirror plane, you don't have to bother perfectly matching the contour of the seat. As you saw, I just drew an arbitrary rectangular surface, and that was automatically trimmed when we used the mutual trim command. That completes this tutorial.